Okay, we're going to take a quick look at what was going to be a demonstration with some discussion, but a core concept that we're going to look at this chapter. And we're going to be looking at describing substances and mixtures. So, what mixes together? How does it mix together? What determines why one thing mixes, why something else doesn't? So we're going to start off with two very simple things. In this test tube, we have water. In this test tube, we have ethyl alcohol. Notice, appearance-wise at least, general characteristics, they're virtually identical, which is which. Now, when I compare these two things, one thing I can do is I can combine them. I can make a mixture. It's 50-50, alcohol and water. It's about half of each. Now you notice there are some lines there called a density gradient, where the light goes differently through different substances. But when I mix them up, in the end, I get a clear solution. So the fact that they mixed tells us something on a very basic level, just that they have enough in common that they stick together. The water molecules will stick together as a group. The alcohol molecules, similarly. But somehow the water molecules and the alcohol molecules have enough in common that they can interact, they can fit together. Now, another example I like to use, sodium chloride, regular table salt. And what I'm going to do is put a little bit of that in the water, a little bit of that in the ethyl alcohol, and a little bit in that mixture, that 50-50 mixture. Now, take a little bit of time, mix these up. And for the first one, there's not really much of a mystery. Sodium chloride in the water, it dissolves. Now, what's important is what dissolves means. It doesn't mean that the sodium chloride is gone. I could taste it and yeah, it's still there. What it means is it has spread out into the water. Now, the ethyl alcohol, same amount of sodium chloride, same amount of shaking. Nothing. You notice when I shake it up, as soon as I stop shaking, boom, it separates. Meaning that the sodium chloride cannot break up into the ethanol. There's something fundamentally missing or different there. Now, if I have my mixture, that's about half and half. It's about half sodium chloride. It's about half ethanol. You can see is it mostly dissolved, but not quite as well. So the effect also is half and half. And you can see there on the bottom, some of the leftover sodium chloride is collected. Now, the analogy I like to use, and this is for those of you who know something about animals, there are certain animals that like to herd. Horses are a big one. If you have a lone horse out in the field by itself, that is not a healthy situation. Horses like to be with other horses. There are some animals that, they're much, much more so that if they're alone, they don't survive long. And horses given the option, will naturally just form a herd with other horses. And goats do the same thing. Now, if you have a goat and you put it out with horses, it will hang out with the horses because they're close enough. You know, it's not a herd of goats. If there is a herd of goats and a herd of horses, it'll join the goats. But given the options, it's close enough that it will mix in with the horses. And the horses will do likewise. You know, horses will herd with goats. And other animals will do that. So what that means on the most basic level is that water and ethanol have enough in common that the particles will mix together. And the same way that the water connects with the other waters, that ethanol can fit into that structure as well. But likewise, the ethanol and the sodium chloride are different enough that they can't. The sodium chloride will not join in with the ethanol, but it will join in with the water. So the water will join both the ethanol and the sodium chloride. So that is something to think about. We're going to do a lot with mixtures, a lot with different types of compounds, and not so much with goats and horses, but gives you a little bit of an idea where we're coming from. All right, see you around.